The lesson outcome for this video is, I can solve linear inequalities by graphing, and this is the lesson on vertical and horizontal lines. So we've already done some practice with solving linear inequalities, but that has only been if our lines have been increasing or decreasing and things like that. Well, what we're going to talk about in this lesson is what happens if we're just graphing a vertical or a horizontal line. Let's look at the first two examples. So this first one says y is greater than 4. Now what we're used to seeing is something like y equals 3x minus 2 or 4x minus 2y equals 12, because we know that this is slope-intercept form and this is standard form. But this doesn't feel like either of those, right? There's a couple of ways that we can graph this inequality. First of all, we could use a table. Anytime you see a variable, x or y, and then just a number on the side, we can use a table. So if I use a table of values, x and y here, we know what this is saying is that we can replace this with an equal sign for just a moment. So y equals 4. No matter what our x value is, y equals 4. So if I put in a 4 here for y and here, okay, whoops. And that means no matter what x value I put in, so let's put in a 1, 2, and 3, I can plot those points and see what my line is going to look like. So I can go ahead and plot 1, 4. 1, 4 is right here. And then 2, 4 is right here. And 3, 4 is right here. Obviously, this shows us that our line is going to be going this direction here. So we can graph it like this. Whoops, what did I forget? Let's back up a second. I'm going to erase that line because guess what we need to do? We need to make it dotted or dashed. Super important that we keep that in mind. After we plot our points, we need to make sure we keep it dashed if needed. So we're going to make a dashed line like so. And now, just like with our regular inequalities, we need to put, we need to shade, pardon me. We need to shade. So how are we going to decide how to shade? Well, the same way as we decided before. And that is we test the point. I'm going to test the point 0, 0. Well, if I put a 0 in for y, right here, put a 0 in for y, I get 0 is greater than 4. Is that true or false? Well, that's false. 0 is not greater than 4, which means that the point 0, 0 is not part of the solution. So we know that the solution is this direction. Okay? All right, now let's look at our second one. All right, again, same plan here. When I know just a value of x or y with a number, I can make a tiny table here and put some values in. In this case, we know x is -8. So if I put -8 in for x, -8 in for x, and -8 in for x, and then put any values of y I want, usually I just use 1, 2, and 3, I can plot those points. So -8, 1 is here, -8, 2 is here, and -8, 3 is here. And you can tell that we're going to have a vertical line at -8. So now again, notice this is also going to be dashed. I remembered to look this time, and I'm going to make a dashed vertical line through there. Okay? And I am graphing this all in the same coordinate plane, so there's some overlapping of my shading and things like that, but that's okay. So now I'm going to test the point again. I'm going to test 0, 0 again. All right, is 0 less than -8? No, 0 is not less than -8. This is not eating the bigger item. 0 is bigger, and so this is, again, false. So I'm not going to shade where 0, 0 is, which means I'm going to be shading this one this direction. All right. There's another way that some people have maybe heard of before about how to remember if we graph a line with y or x as a horizontal line or a vertical line. And I'm going to talk about that on the next screen. Okay, so what we have in front of us here says hoi vux. All right, hoi and vux. And what does that mean? Well, it means this. Hoi stands for, H stands for horizontal. Okay, so a horizontal line. The 0 or the O stands for the fact that the slope is 0 when we have a horizontal line. And then the Y means that this is when we know what Y equals. So if we know the value for Y, and in this case it's equals, but this can also hold true for greater than or less than or whatever the case is. So if we know what Y is, if you think about hoi, it helps you remember that it's a horizontal line which has a slope of 0 if we know what the Y value is. All right. Similarly, we have vux. And vux means the V stands for a vertical line, and a vertical line is like this, right? A vertical line, which U has an undefined slope, and that's when we know what X equals, or if X is greater than or less than something. All right, so it's just kind of a quick trick to remember that a Y inequality is going to be horizontal because of hoi, and a vertical line will be graphed when we know what X is. So if that's a quick shortcut that you like to use, feel free. And I'm going to go through some examples using hoi vux on the next screen. All right, so I'm going to show you how hoi vux can work here. So we have X is greater than or equal to 1. Well, we see the X and we know that vux has the X in it. Hoi vux, right? So that means that if I know what X is, I'm going to have an undefined slope, which is a vertical line. And where's that vertical line going to be? At 1. So I'm going to make a vertical line at 1. Notice it's going to be greater than or equal to, so I'm going to make it a solid line at 1. There it is. And now we're going to do our shading. If I test the point 0, 0, which is right here, I will find that it says 0 is greater than or equal to 1. Well, 0 is not greater than or equal to 1. 0 is less than 1, so this is false yet again. So we need to shade away from that point. We do not have that point in our solution set. So we're going to shade this direction. All right, let's try another one. This time we have a Y. Well, which little term has a Y in it? Hoi does. Hoi vux, remember? So we're going to have a horizontal line at 0. And it's going to be solid again because of that less than or equal to sign. So we're going to make a solid line, and it's going to be horizontal at 0. All right, so a horizontal solid line at 0 is going to look like this. All right. Now, when we test a point right now, can we test the point 0, 0? Well, no, we can't, because if we test that point and it's true, which way do we shade? Or if it's false, which way do we shade? We can't decide. So let's pick a different point. And again, my backup is usually 5, 5. I don't know why. I just typically use 5, 5. So I'm going to test my point 5, 5. Okay, test that out. And so I'm going to have 5 is less than or equal to 0. Once again, this is false. I have a lot of false examples today. Sorry about that. But false means that this point is not a solution, so we are going to shade away from it. So it's this way, like so. All right, let's try another one. Again, we have a Y is greater than -5. So hoi vux, right? Hoi vux. So we have hoi, has a Y in it, which means we're going to have a horizontal line at -5. It's going to be dotted because this is just greater than. So I'm going to draw a dashed or dotted line, right? A dashed line. It's going to be horizontal at -5. All right, so that's right here. Horizontal at -5. Where Y is -5, on the Y-axis we have -5 and it's going to be horizontal. All right, I'm going to test the point 0, 0. So when I test the point 0, 0, I get 0 is greater than -5. Is 0 greater than -5? It sure is. This one is true. So if it's true, that means this point is a solution, which means we need to shade where that point exists. All right, last example. x is less than 6. Using Hoy Vux once again, we see that Vux is the one with an x in it, which means we have a vertical line at 6. It's going to be dashed because of the symbol less than. So vertical line where x is 6. All right, so here's the x-axis. 6 is right here, and it's going to be a vertical line at 6, and it's going to be dashed. A lot of little things to think about here, right? There's my vertical dashed line at 6, and we're going to test a point 0, 0, which is 0 is less than 6. Is that true or false? That is also true. So we're going to shade where that point exists right there, which means we're going to shade this direction. All right. So we are going to practice graphing these in class the next time I see you in class, so we'll go ahead and do that. Have a good one.